All right, in today's lab, we're going to look at Le Chatelier's principle. So you're going to want to turn to Lab 5 in your notebook, in your lab book. And what we're going to really focus on during this video is making observations. So this report, the write-up, is going to really focus on a little introduction, and then you're going to turn around and write a really good set of observations with results and conclusions. So what we're going to investigate is Le Chatelier's principle. And what Le Chatelier's principle says is when a chemical system is disturbed, the system shifts in a direction which will minimize that disturbance. So we're going to see this in action today. That's the point. So here's what I want you to focus on. So as you're doing the lab today, I really want you to focus on these three things. First off, what is the original equilibrium state? So what we're going to do is we're going to set up a reaction. We're going to allow it to come to equilibrium. Okay? So that's going to be the original equilibrium state. What color or state indicated, is it solid, liquid, gas? And what color indicates that you're in that original equilibrium state? So that's part one. And again, taking pictures, screenshots is going to be real important. It'll be great to be presenting a lot of pictures during this lab write-up. Pictures worth a million words, as they say. All right. What's the stress we added? That's the next thing. So you're going to see the technician add stress to that system. Usually it's going to split tubes out, so we'll make a system at equilibrium. We'll split it into multiple tubes. One tube will remain. That's our equilibrium, our original equilibrium indicator. So we say, okay, that's what it looks like before the stress has happened. Then the technician's going to start to stress the other test tubes. And I want you to pay attention to what stress the technician added. Did he add more reactants? Did he take away reactants? Did he heat it? Did he put the test tube in a cold environment? These are the sorts of things that will stress the system. And once that system is stressed, it's going to adjust to the stress to find a new equilibrium state. The nice thing about all these experiments is when you get to this new equilibrium state, there will be evidence in terms of color change, precipitate form, precipitate removed, that sort of thing. So again, lots of screenshots are going to be helpful, and you can run this video over and over as needed. But before you continue with this video, you got to be ready for this, so we want to get you in there. Pause the video, not right now, but pause it once I'm done with these three comments. Go get your lab book, get it open to the page. We're going to start with section A, so that's or on procedure A, so that actual lab procedure starts on part A, lab 5, page 6. So get your book open, have your notebook ready to make observation, and then before we even start, let's write a balanced equation and the equilibrium expression and put it at the top of your notes or in the column of your lab book. So you can always refer to this, so you'll be thinking, oh, here's what I'm stressing in that balanced equation. So let's get this first one done. I'll get you through this. So I'm gonna for procedure A, the scheme is scheme 5 on page 5. So if you'll turn over there, we're going to look at this together so you get used to writing these equilibrium expressions and understanding what the balanced equation looks like. So there's your balanced equation. Iron is suspended in water. Now I'm going to caution you right now, when iron gets suspended in water, it's iron 3+. We don't have iron 3+ on the shelf, so it comes in another form. So we use iron 3 chloride. That just releases the iron 3+. The chloride are spectator ions. We say they're spectators because you look and see they are not in the balanced equation. So for our intents and purposes, when I see iron 3 chloride added, I go, oh, that's my source of iron 3, because chloride's not in the equilibrium expression. Okay? So keep that in mind. Same thing with thiocyanate. That's a nice anion, but I don't have it alone by itself on the shelf to add. It has to come countered with a cation. So what we're going to do is add sodium cyanide, and you'll see that the technician adds that, and in your mind go, okay, sodium's not part of this balanced equation, so it's the source, right? The sodium brings the cyanide to the party. Cyanide's the ones that are going to do the dancing, right? Sodium sits on the sidelines. So sodium, again, spectator ion, sodium plus. So now if I had this balanced equation in front of me, that's going to be in the column of your notebook or in your notes for observation, so you can pay attention to this so you can know, oh, okay, on the left-hand side, that's the iron, and on the right-hand side, that's the thiocyanate. Now, the other thing I'm going to want to put in my notes is just the clues I've given you in the scheme about how you know which side of the equation you're on. So are you back at reactants, favoring reactants? And or as we say in the business, push to the left, then that's pale yellow. And then if you push to the right or you're on the favoring the product side, it's going to be red. So make sure you write in your indicators as well. So as you're doing the chemistry or watching the technician do the chemistry and you go, oh, that just turned red, that means he did something that stressed the system and pushed it to the right. Or if you see the red go away and it gets a little lighter, it may look yellow or even clear sometimes. That means you did something to push it to the left or back to the reactant side. So make sure you pay attention to your clues. Write those in there as well. Now let's set up the equilibrium expression together. Let's get used to this. Remember, it looks like this. It's products raised to the coefficient. Now let's talk coefficients for a second. Everything in here is there's a 1 assumed in front of iron 3 plus cation. There's a 1 assumed in front of the thiocyanate anion. There's a 1 assumed in front of the iron thiocyanate complex. So all these x's and y's in this case are 1s. So they're assumed. You don't have to put them in there. And the thing is, you put products over reactants, and then remember, it's if they're in a state such that they can be a concentration, i.e. aqueous or gaseous. So the equilibrium expression. Because the iron thiocyanate is a organometallic complex, it's what we call something that's coordinately covalently bound together. We signal that with these square brackets. So when you do that, then you can no longer use that to mean molarity. And so you go back to your old parentheses, and that now means molarity in this kind of expression. And so the iron thiocyanate is the product. It's in that normal bracketing. The concentration of that molarity divided by the iron 3 plus cation, the molarity concentration of that, and the thiocyanate anion, the molarity concentration of that. And again, the counterions that brought in the iron and the thiocyanate are not included because they're not part of the equilibrium. They won't, adding more sodium, adding more chloride doesn't shift the equilibrium. And then we say this has an equilibrium expression at a certain temperature. These are all at 25 degrees C. It has a equilibrium constant of 8.9 times 10 to the 2. So we've learned in class that that means it's a little bit favoring products, right? It's a little bigger than 10, so it's kind of favoring products, but you're still going to have quite a bit of reactants unreacted. So this will lead you off in your notebook. So now get your notebook ready, get your lab book ready, and you are ready to start watching the actual experiment and recording observations. And again, I recommend taking some screen captures when you see a significant test tube color come up, and make a note to yourself what it is, after what stress did you get this color, and this is going to be nice for your observations later. All right, now we're going into the lab with Jonathan, and we're going to run the reactions. Again, we're working on part A, page 6, so follow along, and he'll guide you through the lab. So that is a little quick. Oh, so potassium thiocyanate. I thought we were using sodium, but we're using potassium. Again, it's not part of the equilibrium expression, so the cation doesn't really matter, but Jonathan is going to measure out 20 mils of this. Now, one thing technique-wise I would tell you here, and we're just going to mention two things. And one of those is safety-wise, he's not wearing gloves, so that's not acceptable. But the other thing is that he is doing right is he's putting the reagent into its own bottle so that way he doesn't contaminate the big bottle. So that's the right way to handle that part. So now we're going to measure out 20 mils. So remember how we go about this. And the other reagent is so there's the iron nitrate. So we're using nitrate, iron 3 nitrate. So again, in this case, the nitrate, I thought it was the chloride, but it's nitrate. It doesn't matter what the counter ion is, I mean, as long as it doesn't interfere in the chemistry. So this is what we're going to use to provide the iron 3 plus ions. So he did that 20 mil by measuring in the beaker, and now he's going to start adding. So remember what we're doing here is we're not looking to push equilibrium, we're trying to set up the original equilibrium situation. So this is actually creating iron thiocyanate complex, and you can see it in there. It's kind of red, and so that's informative for you because you kind of know what the iron looks like. If it was just iron by itself, it's kind of that yellow. But this is what the complex looks like. It's kind of a nice red complex. Okay. And so this is going to be the equilibrium color. So he's going to split this into tubes. One of the tubes is going to remain untouched, so it can be our reference color. And then the other ones are going to be the ones that we actually do the chemistry on. So we look at the procedure. So we're going to distribute equal amounts amongst the 4 test tubes. So we're running about 5 mils a piece into each tube. So again, in this particular reaction, these are disposable pipettes. He didn't do anything to really pre-clean the pipettes. This is not a precision kind of measurement. So this is nice that you can do just kind of a little, these are throwaways. They came in, you assume they're out of the package, they're probably clean. So again, what we want to remember is we're going to add 5 mils to each of the 4 tubes. And in this one, let's see how he handles it. It's kind of hard to see how he's dispensing, but if you're doing spectroscopy, you're trying to get an analytical measure where it's really important that you do volume correctly. You would not dispense out of the tube till it's completely empty, but he's just basically trying to get roughly 5 mils in. So he's going up to the 5 mil mark and then dispensing out past the tip. And that's okay for this sort of, it's a little less quantitative type work. It's just, we're going to be doing this equilibrium shifting. Again, if you want to be safe, then you would have followed more of Jared's procedure where he was really carefully, in the last lab you saw him very carefully prepping the dispensing pipette. He would have probably been a little more careful prepping the test tubes that you're going into. But all this, again, these are clean. This is clean glassware, and we're just doing equilibrium reactions. So this is going to work pretty good. Another trick on this is if you're that, if it's a little open like this, you could even make a mark on one tube and then just quickly fill the other 4 tubes to the same mark. That'll also get the job done, and that would work. Because once again, it is not as, precise as the other measurement. So this is good to see. Yeah, he's trying to show you he's getting it to the mark at 5 and then dispensing all the way out. Again, not proper technique if you're setting up a calibration curve or something where the volume is critically important. These are kind of qualitative labs where we're just able to shift equilibrium with kind of gross approximations. All right. So building the last tube. Pipette. It looks like Dr. Thompson. There I am in 2 places at once, talking to him for a minute. Sorry, that just... Oh, and there you go. Dr. Thompson's saying, hey, you better put your gloves on. Here we go. This would be a good safety question I might ask you about whenever you're dispensing any chemicals. It's always safer to go ahead and use these gloves. We have them available for you. They come in all sizes, so you want to make sure you do that. And then, and this is good. Actually, this is good. So what you saw was that one glove didn't work so well. So, you know, instead of just trying to limp along and make it work, he's going to get a new one on. That's important. All right. So now we're back to our last tube. Correction made. And again, if he had measured that, again, it's kind of qualitative work. He could just basically just run the 5 mils out, or he could just pour out of the beaker at this point. Okay, so at this point, we are getting our 4 tubes ready. We are done with step 2, part A. Page 6, the 4 tubes are ready. Remember, we're going to keep one intact. That's tube. It's going to be unchanged. That's going to be our reference color. So now we're ready to go to step 3. To the second tube, add a few crystals of potassium thiocyanate. So stop and think about what you're doing at this moment, because you're actually adding more reactant, right? If you look at, that's why I want you to have that balanced equation. This is adding more thiocyanate anion. So which way should, this is the stress, adding more thiocyanate. So let's see what it does to the color. So he adds that in there. It does a little swirling, and you can see it at the bottom. It's definitely driving the equilibrium. This is a good chance for him to use some technique he's probably not as familiar with, but if you hold that tube firmly and just snap it with your finger on the bottom. But there you go. And again, that would have been a good picture, and you might want to wind it back and screen capture. That's the stress, and the response was how it acted. Now we're going to do something similar. We're going to add more iron nitrate. Okay, so this would be tube 3. We are now on step 4. And again, once you add that, you're going to see a response. So you can see that second tube, what it's done. But now we're going to do the third tube. The stress is adding more of the iron. Remember, the nitrate is not part of the equilibrium expression. Let's see what it does to the equilibrium. All right. There he goes. You can kind of see it gathering at the top. Now it's working its way down. That also is going to be pretty obvious. It's a good little lesson in from our kinetics too, is when you add things in the liquid state, look how quickly they can react, because there's a lot of surface area there. Whereas the thiocyanate, when you added it took it a minute. So after this is done, it's going to quickly return to a new equilibrium. This is a great time to, you might want to wind back and get a picture of that. Finally, we're ready to add the sodium hydrogen phosphate, which is step 5. Now remember that the ammonium hydrogen phosphate is actually something that's able to complex with iron 3+. What it does is it makes a complex similar. It's a clear complex, but the point is, as we study these reactions, it would be removing iron 3+, one of the reactants, from the equilibrium. So it's going to adjust accordingly. So here he is. He's looking that over for some reason, but Yeah, we're gonna hopefully add that to test tube 4. There you go. Add a few crystals. Again, this technique is not what we do. The best way to do that is to have your own spatula, right? We don't want to contaminate that vial. Boy, look at that shift equilibrium. That's awesome. So just a little bit to, there we go. That's going to be a great picture. There's a product, or the new established equilibrium. So there you go. That completes step A, and we'll see if he gives us one good shot with everything done here. We'll see. There we go. And I think I'll also upload a picture that he may have made for all these tubes. So now you know how they're set up. On the far left is the standard. On the far, he's adding more. He wasn't happy with something there. On the far left was the standard. The next one over is where you added the thiocyanate. Then the next one over is where you added the iron 2 plus, which he's kind of running back through and redoing, or 3 plus. And then the last one is going to be the crystals of the sodium hydrogen phosphate. All right. All right, he's taking a minute, but hopefully we'll get it back in the shot here. And there it is. Left to right. Color standard on the far left. The original equilibrium. The next two are the ones that have shifted by adding reactants, and the one on the right is the one that shifted by removing reactants. Okay, at this time you should be ready to move on to part B, the next video.